I just pushed the plus button.
Yes.
Or the...
No. Just this?
This one, the enter button.
Yes.
Okay, good. Good afternoon. I'm really happy that Benedetto invited me to come over, because every time I can come to Europe, I can also come and visit my family. I migrated to the United States 30 years ago, so always happy to be back. My talk is about the role that systems models play in this whole discussion about ecosystem services. When I started the conversation about ecosystem services, I came in there as a systems modeler. And I had to do an awful lot of learning what other people knew about ecosystem services before I actually knew what it is that I was supposed to do. So I'm going to go through a little bit of history, how that worked and how that evolved, and how my career is where it is right now. So in, I think it was 2002, together with Roelof and Matt, we published this paper on description, valuation of ecosystem services and goods and values. We worked in this group at the Gund Institute in Vermont together with Bob Costanza. So we were trying to follow up on the 1997 paper, and said that paper was done kind of really fast and we need some standards on really what this thing is. So the four basic questions that were asked in that paper is like, what is value? And then what is of value? How is value accounted for? And then how we might expect value to change. So I think from that paper, like the last 15 years, that is what a lot of the discussions have been on ecosystem services. How do we wrap our minds around it? In those 15 years, a lot of technology came along. A lot of data became available, things that weren't there. So we actually had a really exciting period of 15 years of new thoughts, the Values Project, other projects all over the world, and so on. So I think when we said what is a value, the perceived importance of goods and the service comes out. I don't think that was not what the discussion was about. But the discussion was much more about what nowadays is kind of summarized by the system of the UN. The UN accountants actually, for the last 4 or 5 years, have had discussions, meetings, group, with all kinds of ecosystem service thinkers to say, well, it's not necessarily what is a value or how it's a value counted for. It's like, we just need the decision what that is so that we can account with it. And if we feel like it's not the right thing, maybe we should sort of institutionalize it, come back every 10 years, make a new list, all agree upon it. And because it's like once you know what it is that you can put on the ledger, that you can account for, you can actually tell people to go do that. So the UN statisticians now have, I think it's like 128 countries that decide that they actually want to go and put this kind of accounting in their national accounts. So that means from that level, it's going to be coming back to your local decision makers, and everybody is going to know what they're talking about. So those are really good discussions going on. So how do they summarize it? It's like, what is a value, spatial area, good classification of ecosystem services. The Europeans do that different than the Americans and the Africans, but let's have some standardization in that we all know what it is. The indicators, how healthy are these systems, so standardization of that. And then a lot of it is the description and classification of ecosystem services. So people in economic systems did these classifications in the 1930s, and that ended up in the ISIS and NAICS kind of classification schemes, and it's been used very much in looking at economic progress in areas. So we wanted to extend that to including ecosystem services. Well, the people at the UN are all accountants, and they know better how to do accounting than I do. But they say to actually do the accounting, we need to have these valuation concepts, methods for the key ecosystem services, and then we need to be accounting from what it is, like when the data come in, did this get better, did this get worse? When I talk to them about what I do, they say, no, we don't do modeling. We just take the data and we put it in an account, and every year we'll give you a status on where we are, how we have been done. So a question 4 is how we might expect to value the change is something that the UN and the accountants and a lot of the discussion really hasn't discussed yet. It's like, what are we expecting and how are we going to live in this future world? So that is where the predictive modeling comes in, the systems dynamics model, where we're going to actually have to answer questions like, where does the climate change thing happen? What are the social changes we're going to see? And what is going to happen to our ecosystem services? So that becomes something like this. When I designed this accounting framework, I was basically channeling Herman Daly's paper in 1968, who actually came up with that concept. Herman Daly is one of the grounding fathers in ecological economics. And how he put it, like, there is this economic sector use and sector make. That is what most economists think of as equilibrium models, like economic sectors feeding into other economic sectors, and that is how most accounting in the world has been done. The idea of ecosystem services is where we take the ecosystem services, how do they impact these human interactions, and how do they actually go as economic impacts. That is something that Benedetto just talked about. It's like we're doing something of a life cycle analysis. As an ecologist, I'm like, there is this thing of ecosystem processes, actually understanding what the ecosystem do, that produce the ecosystem services and actually get the impacts. Well, I privately start calling that the afterlife cycle. So the systems modeling, it's like human interactions happen, they have ecological impact, that impacts the processes, that gives you back a number of ecosystem services that is going to have an effect of how humans actually interact with each other, that is going to have new kinds of impacts, and so you can see that the models become like causality models that which systems models are. So the models are not necessarily based on data, they're based on stories, causalities, and that is important if you work in data poor areas such as the future, or as in what if we did this or what if we did that. So totally no data. The only thing you have is like kind of talking to a lot of people what they think which cause might lead to the next result. So the introduction of dynamic systems models. So here is Benedetto talked about the gumbo model. So this is the very first time I actually did a model that went through this whole matrix. It was published in 2002. And I showed the development of ecosystem services over between 1900 and 2100. I calibrated an awful lot of that up to the year 2000, and after 2000 I actually came up with a number of scenarios, what-if scenarios that are expressed there on the left. There is the business as usual scenario, the black one. It's like I don't change anything. we're doing, keeping everything like it is. And then there were, the scenarios were kind of like, we're assuming this to happen, and this is how we will react to it, and then we gave it some fancy names. So I don't really want to go through what exactly these scenarios mean, but what I want to do is point at the importance of how scenarios are to be used in these kind of models. So I call that scenario models. So a lot of times you talk to people and you say, what do you think? And then you need a model to actually being able to calculate through that and test that again. Is this like a potential outcome or not? So it's all about conversation and stories. So what is it really that we try to achieve in scenario models? We're not trying to predict the future. We don't, so confidence intervals are not really that important. We're just exploring what we know and what we count to the potential. So it's like thinking outside the box, thinking different things. So it's all about exploration. Having said that, we're not looking for calibrations. There is a way of validating these models, and that is like as the future comes along, data becomes available. So we can actually look at models done in the past and see how well their scenarios follow the trends. Like a very important example of that is the work of Dana Meadows and the Club of Rome, who did models in the 70s, and now people are actually following their outcomes with very interesting discussions. As I said, the models are based on causalities. They're not based on statistical relationships. What we're looking for a lot of times is emergency. Do we see things like patterns emerge that we didn't really expect there? Are we... And then, of course, scenario models is all about solutions. Based on what we know, what we explore, how we train our mind to think, how would a what-if scenario play out in this system? And are these really the solutions that we're looking for? So in that way, anyway, that's what we're looking for in scenario modeling. So after Gumbo, and those papers, I shifted a little away from academic thought, and I became more like a consultant kind of guy, actually working with different groups. I started working for the Environmental Protection Agency, and I worked for some of the tribal people in the United States. And they were like not so interested in what was happening with the globe, but they were interested in what happened to their watershed or to a particular thing. And so I had to bring back the global picture back to what I call landscape models and to understand these general unit models. So what I wanted to do was answer questions like this, and I'm very involved in this particular project. It's where you have different stakeholders, different people, all relying on this research of the lake. Catching one fish affects the ability to catch other fish. Catching one fish benefits one person, but hurts another person. And so how can we optimize an ecosystem, life cycle, like food webs and nutrient cycles and all that to help most of the stakeholders in that area. And what I want to do is with these models is actually answer scenarios with real value. So it's not me coming up with these questions, but it's like the managers of the area. In this particular project, they're thinking of putting fish cages in the lake, and they want to know where to put the fish cages, what fish to put in, how that is going to affect the lake and the wild fisheries and all that. So that's the kind of questions I'm trying to model through and give answers for. For that, I published this paper on the MIMES. It's what I call a dynamic GIS system. It includes systems dynamics models as human models within spatial units. And spatial units have horizontal exchanges and exchanges over time. So output of these models are movies that simulate the real thing. They get to be pretty complex. And learning from these models is like how you really learn from a real system. You put sensors in it, and you ask it questions, and you see if what it is. Anyway. So this is the MIMES model. It's a set of equations of a set of locations, what basically makes up a map, and the attributes to each location are simulation models that have something to do with the atmosphere, lithosphere, hydrosphere, the biosphere, and human cultures and economy, what I call the anthroposphere. So a model kind of looks like this. It's written in a simile software, and normally I go through this, and it's to go in, but I don't. I guess that doesn't work in this program. But you can see that like fish attributes is everything we know about these 13 fish: how long they are, how fast they grow, when they die, what they eat. There's water particle attributions, that is like suspended sediments, algae, different algae, zooplankton, how fast they grow, all that. There is time series inputs on weather data, temperature, rain, and then all that is happening in these locations, and then the polygon outputs are all the movies that come out. Like you can look at many different things at the same time, and then you can sample certain locations out of that to actually give you time series, so you can look time series. So working with a model like that looks like this. This is one page out of many different pages where you can move sliders around and then look at movies going on like this. So this particular run is at time 120, and I'm looking at the output of one of the cells while I'm also looking at the patterns over time and space for all these cells. And this particular output on the left is the young Nile perch, where they get born and where they congregate and grow up. So I just come back from Uganda and had a big workshop and had all kinds of fisheries scientists playing with these things and telling me where this is not happening and we don't see that, and wow, I never thought of that. So now when I come home, I have a lot of work to do to make it all work. So anyway, other project I'm working on is the Tonle Sap in Cambodia, where we're looking at a flood pulse system, where the monsoons every year make the area of the lake twice as big or 3 times as big as in the dry period, and where people actually live on these floating villages, and they go with the water up and down. And last year they had rain, but before that they had 2 years they didn't have rain, and so they didn't catch their fish, and so there was a lot of misery there. And then these are kind of time series outputs where we're now working with. Other project I'm working with in the US is with the EPA, where I'm actually looking at the sustainability of Chicago and how long that system. So I'm working with people thinking about systems, models like that, and I'm translating that back into MIMES kind of models to look at. So those are kind of where MIMES is right now. Do I have time, or I'm done? I'm done. So,
please conclude that.
So this is the work what I'm very involved with in the EPA. So, and there are many more projects, but that would make a long list and a lot of explanations. So maybe there are questions. And of course, there are all the value projects. That
Yes, we can even postpone to later.
Okay,
So,
good.
Because in the end, if you are part of the round table.
Yep, absolutely.
Question, please do it.
All right, thank you.
Thanks, Roel.